This is Investigating Diffusion by Philip Longueuil, Kathryn, Rojeck, and Zach Howell.
In this lab, we examined the movement of beads suspended in liquid. We varied both the liquid the beads were suspended in and the size of the beads in order to determine how changing these two variables affected the motion of the beads. Among the tests, the 2 micrometer beads in corn syrup were the only trial that did not show directed diffusive motion. Overall, we interpreted these higher velocities to mean that the beads diffused faster. Likewise, more viscous liquids showed slower average velocities. The force diagram for the bead demonstrates the gravitational force pushing down on the beads and the buoyant force of the liquid to bead. There is a resistive force of the liquid on the bead as well as an equal and opposite force due to collisions with the liquid molecules. For example, because the corn syrup has a higher resistive viscous force, the velocity is slower and the beads in water and dish soap. There are 2 different scientific principles that are relevant to this experiment. The first of these is the second law of thermodynamics, which states that entropy or disorder in an open system is always increasing. This means that the beads will tend to evenly disperse themselves throughout a solution through diffusion because this would be the most disordered and that is the lowest energy macro state. The second of these is the law of conservation of momentum. This is why the beads move in the first place, because the molecules of the solution collide and transfer their momentum to each other as well as their beads.
In order to conduct our experiment, we pipetted 2 micrometer polystyrene beads that were suspended in 3 different liquids, water, dish soap, and corn syrup, onto a microscope slide. This was to examine the variable of the liquid. Additionally, 5 micrometer beads suspended in water were also pipetted onto a microscope slide. This was to examine the variable of the size of the bead. A 59-second video was taken of each of these 4 different suspensions under the microscope. Then, the videos were examined using the tracker software in order to determine the velocity of the 2 different beads per video. These values were averaged together to get an average velocity. Though it was expected that the motion of all the beads would be seemingly random, the motion of the beads in several of the videos seemed to be more directed. And this is likely due to the fact that the bead suspension was not pipetted perpendicular to the microscope slide, giving the beads an initial velocity.
Due to the fact that the beads were already evenly suspended throughout the liquid and they were dispensed onto the microscope slide, it was expected that they would have random undirected motion. This is because they were not flowing from high to low concentration, meaning that entropy should have already been at its maximum. This random motion is caused by collisions between the beads and the molecules that make up the liquid. Based on our measurements, we determined that the average velocity of the 2 micrometer beads in water is greater than that of the 5 micrometer beads in water. This makes sense, as the smaller particles will have a higher amount of surface area relative to their mass, so the transfer of momentum due to collisions with water molecules will cause a greater change in velocity in the beads of a smaller size. The equation that states momentum equals force multiplied by velocity demonstrates this fact. When we re-examined the velocities of the particles in the 3D diffusion code, we saw that the computational modeling demonstrates random motion. Compared to the polystyrene diffusion, the 2 micrometer beads in corn syrup have random motion, but the rest of the tests demonstrate directed motion.
A possible error in the experimental design is that the velocity of the beads is difficult to define because the particles do not move in a straight line, meaning that only using one axis and tracker will not give an accurate measurement. Additionally, it is difficult to assign the correct length to the calibration stick and tracker.